Hello guys, my name is Vinay Balaji and welcome to another professional prep video. In today's professional prep video, we will be talking about derivative tests. So to begin, I'm going to recap the first and second derivative test, and then we're going to go into this problem that talks about the first and second derivative test. Alright, cool. So in essence, I'm going to draw a graph so it can help you guys out. So this can be our first derivative test. And this can be our second derivative test. So say if we had, alright, say if this was 0, 1, and 2. Negative 2. My apologies. Same case here. These are not drawn to scale, by the way. Let's just go positive, negative, positive. Alright, so what I drew here is called a sign chart. Alright. So essentially, a sign chart has these signs, so it could be an easier way to find out whether it's a maximum, minimum, or neither. So obviously, the sign chart might not make sense to you at first glance, but basically, what the positive means is that the point or the graph before -2 is above the x-axis. If it's negative here, that means it's below the x-axis. Positive, like previously, it is above the x-axis. Same thing with the second derivative test. The sign chart just basically indicates whether the part of the graph is above or below the x-axis. So now I'm going to recap exactly what sort of combination results in a minimum or maximum. So when it goes from positive to negative, that is a maximum in the first derivative test. When it goes from negative to positive, that's a minimum in the first derivative test. The only way where it would be neither is, example, say if this was positive, right? It would stay positive, positive. Then in that case, it would be neither. Alright, so now let's go to the second derivative test. The second derivative test basically states that if a point is above the x-axis, that means that it is a local minimum. And if a point is below, maybe use a different color. Let's use like purple. This indicates a local minimum. Alright, so that is the difference between the first and second derivative test. One thing that's important to know about the second derivative test is that if a point is at 0, it means that that point is inconclusive, and you have to use first derivative. Alright, so if a point is at 0, inconclusive, you have to use the first derivative test. So now let's dive into this problem. Obviously you can pause the video, but to save some space, I am going to erase the drawings that I just made. I'll make this eraser a little bit bigger. Just gotta make sure I don't erase like any of the word problems. Alright, cool. So the problem reads, state the x-coordinate of the critical point of f of x e to the x squared minus 3x squared minus 24x. For each critical point, state whether it's a maximum, minimum, or neither. Show the analysis that leads to your conclusion. So the first step is to take the derivative of e to the x squared minus 3x squared minus 24x. So to take the derivative, we already know that e to anything is just itself, right? So it will stay e to the x squared minus 3x squared minus 24x. But since there is this value here, this long polynomial, you have to use something called the chain rule. So basically, you have to take the derivative of this. Alright, so to take the derivative of that, it would be, wait, my apologies, I actually made a typo. That's a 3. The reason it's a 3 is just because it'll come out good at the end, and if it was a 2, it wouldn't really look that nice at the end. So sorry, just make that a 3. All right, so this is a 3, that should be a 3. So f prime of x equals e to the x to the third minus 3x squared minus 24x times, and then we take the derivative of x cubed, so it's going to be, let me do it in the same color, 3x minus 24. Alright, so that is how you take the derivative. Now, this is what f of x is equal to. Now, what you should do is set this equal to 0. When setting this equal to 0, you get the critical point. Alright, so now that we set this equal to 0, we have to figure out what times this will get 0. And we know that anything times 0 will get 0. So if one of these, like, I guess, expressions, if one of these expressions results in 0, that means this whole equation results in 0. So just for simplicity's sake, let me use a different color. Which one have you now? Green. Alright, so let's just use this equation and set it equal to 0, and then use the first derivative test to find out whether it's a maximum, minimum, or neither. So we have 3x squared minus 6x minus 24. Alright, and we set that equal to 0, so we can factor out the 3, so it's going to be x squared minus 2x minus 8 equals 0. That is also equal to 3x plus 2, x minus 4, okay? And we set that equal to 0, and we can clearly tell that our critical points are negative 2 and 4. These are my critical points. Alright, I hope my handwriting's decent. I'm trying to do this quickly, so to keep it concise. So now, like I said previously in the beginning of the video, we need to create a chart, a sign chart. Alright, so negative 2, keep it like that, dot, 4, something around here. Alright, so these are our two possible candidates. So what we need to do is just put a value before negative 2 into this equation here. Or, well, into that equation, and then we see if it's positive or negative. So, let's try negative 3. We put negative 3 into that equation, and that certainly gives us a negative number. Say if we put 0, it gives us a positive number because e to the 0 is 1. And with for 5, that's going to be a positive number. Wait, time out. Oh, okay, I see what I did wrong. You're supposed to put it into this equation, like this giant one, not just that. So, negative 3 should give us a positive number, negative number, positive number. Yeah. So that is what you are supposed to do. And obviously, looking at our previous rule here, when it goes from positive to negative, like I said before, that means x equals negative 2 is a maximum. And since it goes from negative to positive, that means that it is a minimum. Alright? So that is what, that's how I use the derivative test. So we know that negative 2 is a max, 4 is a minimum. And I would like to clarify what I said earlier. You do not put that into this equation. You put it into this giant one over here. Because you're doing the derivative test, right? You can't just do it on the normal equation. You know, you have to keep it, since it is implying first derivative test, anything you do with this test, you have to do it with the derivative. I had the freedom of using a calculator, so I just plugged it in rather than doing it all out. If you were supposed to do it all out, I'm pretty sure a teacher or a professor or someone will give you like a much easier problem. but I just used a calculator just to approximate that, whether it would be a positive, negative, or positive value at that point. Oops. Okay, cool. So, just one thing I want to rehash before I end this video is just that anything that you do with the first derivative test, stick with it with the derivatives, okay? Because what I did was I had like a bunch of oh well, sorry. Basically what I did was I thought we had to use this equation, right? But actually we had to use this equation because anything involving the derivative test, you have to input values in the derivative form, not the normal form. It's a mistake that I commonly make multiple times. I don't want you guys to make the mistake, and I hope that you guys understood that when I was creating this video. Basically, when you come to the point where you have to plug in values into the sign chart, use the first derivative equation. Same thing with the second derivative. If you want to do the second derivative test, you have to find the second derivative of that equation. Alright, I hope that makes some sense. I hope you guys learned something from this video. If you have any questions or need any further clarification, our contact information is located in the descriptions. Also, feel free to put them in the comments below. I hope you guys learned something from this video and that I was helpful to you. Other than that, I hope you guys have a really good day. Thank you.